All right, so as I mentioned, we are going to be moving into graphing of other trigonometric functions, right? So yesterday, or not yesterday, um, Thursday of last week, we learned how to graph our sine and cosine functions. If we know how to graph sine and cosine, we can easily graph cosecant and secant, okay? Because remember, they're inverses of each other, right? And so if we graph, so this, for example, here is we're looking at our cosecant graph. So if we graph our sine, which you'll see that dashed line there is our sine graph, then our cosecant, we just put asymptotes everywhere that it's zero, right? Because if I have 0/1, the reciprocal is 1/0, that's undefined, okay? So graph it, even if it's with transformations or whatever. So what you want to do is you'll put it in there as the, just take out the word cosecant, put in the word sine, graph it, and then you can put anywhere the graph crosses the x-axis, we're going to put asymptote there. And then you can see at each of the peaks and valleys, we then just get this parabola, okay? And that's all there is to graphing our secant and cosecant. So secant is exactly the same. You'll see this over here, except we're graphing our cosine, and then everywhere there's this, it crosses the x-axis, we're going to put an asymptote, and then it's going to be the parabolas on the peaks and the valleys of that sine or that cosine graph. Okay. Any questions so far? Okay. So here's a little bit about the cosine or the cosecant and the secant graphs. So the domain, right? Your domain is for your cosecant is going to be multiples of pi, whereas your domain of, or so your domain can't be any multiples of pi for your cosecant, and it can't be any multiple of pi/2 for your secant, right? So that's where your graphs would be, have those asymptotes. The range is going to be, our y is going to go between -1 and it's going to be like greater than -1, right? So you can see that here. It's going to be, so it'll be, here's -1, here's +1. And so we can either be +1 or greater, -1 or smaller, but we can't be in between in that range. So that's really what this here is saying for cosecant, and here for the secant. There's no amplitude for these because they increase or they decrease without bound. That means they can go all the way up to infinity or all the way down to -infinity without a bound. So we don't have an amplitude. The period, just like sine and cosine, is 2 pi. You've got those vertical asymptotes at pi, at every multiple of pi for our cosecant, and every multiple of pi/2 for our secant. And then our cosecant is got symmetry with the origin because it is an odd function, and our secant has symmetry with the y-axis because it is an even function. Okay? Questions? All right, so let's look at a graph here. So this example we have are the graph y equals -2 cosecant of 3x. So again, as I mentioned a while ago, let's just convert this to the reciprocal of cosecant is sine. So let's just graph -2 sine 3x first, okay? So the first thing we want to do is, what is the amplitude? The amplitude is the absolute value of -2, so that amplitude is 2. So what that's telling us is if we don't have any vertical or any vertical shift, which that here, this is +0, right? So that means we're not shifting up or down. So then I'm going to, for my regular sine, it's going to oscillate in those bounds between the amplitude, okay? Now, if I'm talking about the amplitude for my cosecant graph, there is no amplitude, right? But right now, we're strictly talking about our sine graph, okay? So that is, we can look at the period. Remember, the period is 2 pi divided by b. So that is, well, I do the absolute value of b. So that's 2 pi divided by 3, right? And we also know because of the negative that this is going to reflect across the x-axis, okay? So instead of starting going up, we're going to start at 0 and go down, okay? And then we have that 3x has intercepts at even multiples of pi over 3, okay? So we can do the parts that we want to for equal parts. Right? So we take our 2 pi over 3 divided by 4. That's the same as timesing it by 1 over 4. So that is going to give me every pi over 6 is my equal part. Okay? And the last thing that we want to do is to determine our phase shift, which we could have done the phase shift actually up with before we did the 4 equal parts. It doesn't really matter because we're really just trying to gather as much information as we can before we do it. But I'm gonna just go ahead and shift this down and say our phase shift. Remember that phase shift is our C divided by B. In this case, my C is, I don't have anything out here, right? This is just -0 if I had the parentheses here. So that is 0 over B, which is 3. So my phase shift is none. So that means I'm not shifting left or right. So this really just tells me no shift. And then my vertical shift, since D equals 0, there's no vertical shift, right? So that's like +0. And I'm going to go ahead and change the color of those. Okay, so that's how we can presume that. Okay. All right, so this was, get my blue. So this was A, B, C, and D. Okay, any questions so far? Okay, so now we know equal part. We're going to start at the pi over 6, right? So we start at pi over 6. So then our first point is, I'm going to just put that up here, is going to be that 0 plus pi over 6. So that equals pi over 6. Our second point is going to be the pi over 6 plus pi over 6, which equals pi over 3, or it's 2 pi over 6 or pi over 3. Then we have 3 is going to be pi over 3 plus pi over 6. So that is 3 pi over 3 or pi over 2. And then our fourth point is going to be pi over 2 plus pi over 6. And that's 4 pi over 6, or reduces to 2 pi over 3. Okay? So if I wanted to graph this, I know that if we're graphing just this in general, right? It would be, so we're going to start here at the 0, 0. Normally, right, we would go up. But remember, we're reflecting across the x-axis, so we actually have to go down first this time. We're going to go down to the -2 because that is our amplitude. Then we'll be back up on the axis for pi over 3. Then we'll be above the axis and then back down on the axis. So we can erase these red lines that helped us to determine what it was that we were going to do. Excuse me. And I'm going to go ahead and just continue, excuse me, this pattern so that we can graph a total of 2 periods here, okay? So this is y equals -2 sine of 3x, right? But that's not what we were asked to graph. We were asked to graph the cosecant. So everywhere we see our graph crossing the x-axis, we need to come in here and put in an asymptote. Okay? Okay, so we have our asymptotes built in. And now all we need to do is on our peaks and valleys, we're just building those upside down parabolas for the low ones, and we will do upward parabolas for the top one. Okay? Question. Okay, so now you can see that we've added this +1 over here, right? So I'm going to see if I can get this graph to overlay on this one. Okay, so it's the exact same graph here, right? Except now we want to shift everything up 1 unit. Okay, so if we're going to shift everything up 1 unit, that is, we're shifting everything up 1 unit. Okay, and that's all there is to it. So you can see now that this one is oscillating from -1 to +3 because everything shifted up 1 unit. Okay? Question. And so that's all there is to graphing our sine, cosecant and secant graphs. But I do have a few more examples to do with like our tangent and cotangent, which are slightly different than this. And so the one thing I will say is you guys are going to get a lot of practice doing these other trigonometric functions in your homework, but you will, on your exam, you will get a sine or cosine graphing, most likely, not one of these other ones. I haven't written the exam yet, but we've got a lot of material to put on the exam, and if we're only putting 20 or 25 questions, then we can't do one of every kind. So we'll do the more common kinds on the exam, and then you can do these other ones in the homework. Okay. Questions?
Would you mind going back just for 1 second?
Sure. Do you want the bottom one?
Yes, please. Is it always that the vertical asymptotes are at, like, is it that it's where it crosses X, or is it where it's that it bounces back to the original one?
Yeah, so it's back where it would be your, because ultimately it's what's going to make that when you flip the reciprocal, when it's going to
Okay.
make you undefined.
Ah, okay. Thank you.
Uh-huh. Good question. All right, so now moving into the tangent and cotangent graphs. The tangent function, if you recall, both tangent and cotangent, those are also odd functions, right? And so they also have symmetry with respect to the origin. The thing with the tangent function, remember that sine over cosine. And so whenever my cosine is equal to 0, my tangent is going to be undefined. Okay. And remember from the previous sections that our period for our tangent is just pi instead of 2 pi. And then we have vertical asymptotes anywhere our cosine is equal to x. Okay. Similarly, with the cotangent, that is our cosine divided by our sine. So anywhere we have anywhere that we'll have a vertical asymptote, anywhere that our sine is equal to 0. Okay. And then so I give you these 2 pages and this one as well, more for information, just so that you have it available to you. But when you look at our domain here, right? So for our tangent, we can not equal any multiple of pi over 2, just as with our cotangent, we can't be any multiple of pi. The range is all real numbers, so it goes from negative infinity up to positive infinity for our y values. Therefore, it's not bounded, and so there's no amplitude. The period is pi. We'll have those vertical asymptotes you see for the tangent is at odd multiples of pi over 2, and for cotangent, it'll be multiples of pi. And then both are odd functions and they have symmetry at the origin. Okay. Questions? All right. So very similar to what you guys got with the sine and the cosine. I give you here the tangent and cotangent. And so again, remember our period here is pi now. So when you're trying to determine a new period based on a transformation, you want to do pi divided by b and not 2 pi, right? Because our period is only pi. And then similar ways we're going to be able to determine those asymptotes, but the key difference here is remembering for our tangent, you're going to do it from negative pi to pi. So if you think about this here, tangent can go from negative pi to pi. So it can occupy this space, right? But our cotangent can occupy from here to here, and it can occupy this space, right? So here's where the tangent is negative, here's where the cotangent is negative, and they're both positive in the first quadrant. And this will all come into play in the coming sections when we start talking about inverse functions, because remember, we're bounded with our cotangent. This is our boundary, right? We can go from 0 to pi. We have an asymptote at 0. We have an asymptote at pi. Remember, vertical asymptotes, you can't actually cross them. So if I start here and go around, I can't actually cross into this round. Okay? And so that's part of that. Similarly, with our tangent, I can be anywhere in this space, but I can't actually cross the line. And so that is why we have those vertical asymptotes. Okay. All right, question. So let's look at just graphing an example of this function. So we're given a graph that says y equals 4 tangent 2 pi plus pi over 3. So the first thing that we want to do is let's go ahead and do our negative pi over 2 is less than. Notice there's no equality here. Now it's all the things inside the parentheses here. So 2x plus pi over 3 is less than pi over 2. Again, just to point out and to reiterate, there's no equality with these here. There's no equality because that's an asymptote. Okay, so let's go ahead and minus pi over 3 from both sides, or all sides. When we minus pi over 3 from all sides, we get negative 5 pi over 6 is less than 2x is less than pi over 6. Okay. Now let's divide all sides by 2. And that's going to give me negative 5 pi over 12 is less than x is less than pi over 12. Okay. So at the tangent, we now want to calculate a midpoint. Okay. So to calculate our midpoint, we take those two ends. We take this negative 5 pi over 12, add to it our pi over 12, okay, and divide that by 2. So that's really, we're just trying to look for the average way of these. So we have this space here, and then we have this much more. So basically, if you look at this, I have 1, 2, 3, 4, 5, 6 boxes. So my midway point should be, it should be here, right? Because I have 3 boxes on this side, 3 boxes on this side. So let's see if when we do our calculation, if we get this negative pi over 6. So when I do 5 pi over 12 plus pi over 12, that gives me negative 4 pi over 12 divided by 2, which is times 1/2, right? I mean, so it's divided by 2. So we'll multiply that by 1/2. And this is going to give us a negative pi over 6. Okay. So I could write it a little differently here too. So if we did it divided by 2, so that's negative 4 pi over 12 times 1/2. That goes like that. This cancels further and becomes a 6. So it equals negative pi over 6. And that is exactly what we said, right? And that midway point is our x-intercept, the one place that we are. So we could put a point here. These two endpoints, this and this, are my asymptotes. Okay, so I have an asymptote at negative 5/12 and positive 1/12. I could go on and do a second cycle, right? So I would have another asymptote out here at 7/12. I would have another midpoint, 1, 2, 3 here at pi over 3. And then we could just do this, okay? You could do a calculation. You could say, well, what if I let pi over 2? I plug pi over 2 over into for x, solve it out, and I could get a more precise value. So you might end up having to do that for your Alex homework. If you were to get one of these on an exam, it would be an eyeball sketch is close enough. Okay, question. Okay. So I want to point out a different one. So where we're looking at the negative of a tangent graph. Okay. And so in this case, pointing this out, I don't know why that's not letting me write up there clearly. And so what I want to point out here, right, is if we have a graph like this, as you saw with the original ones, if we had a point somewhere like this and our tangent runs like this, right? That's what our tangent looks like. Well, now when we're talking about the negative of it, now it's going to run like this. And so that is a negative tangent. Okay. All right. Question. So I'm pointing out this is negative. Okay. So let's take our negative pi over 2 is less than this piece here. This is a increased, right? This is telling me I have a vertical. I'm going to shift my graph up 2. So I just need this 3 pi over 4x is less than positive pi over 2. Okay. So I can multiply everything by 4 over 3 pi. So if I do 4 over 3 pi, you'll see this cancels, leaves me with x here. So I'm going to have 4 over 3 pi, 4 over 3 pi. One of the things we could see is that the pi is going to cancel in each of those. And the 2 is going to cancel here. And so that's going to leave me with a negative 2/3 is less than x is less than positive 2/3. Okay. So let's find our midpoint. We have negative 2/3 plus 2/3 divided by 2. That is 0 divided by 2. So my midpoint is at 0, 0. And I need to move up 2 units. So here's 0, 0, but I have to transform up 2 units to right here because our graph is every 2. Okay. We're going to have asymptotes are going to be on our endpoints here. Remember, this is our asymptote. So we come in at negative 2/3, positive 2/3. And if we weren't shifting, it would look something like this. But remember, we are shifting our graph up, so we can take that, shift it up 2 units, and that is positive look of it, but we want to do the reflection of the for the negative, so that reflection would look something like this. Okay? Question. All right, so that is all there is to section 4.6. I think it's a little early to take a break, so we'll go ahead and start into section 4.7. If it goes to, past 7:30, then we'll take a break, but I don't think that it'll go past 7:30. And that way I can get you guys on your way to working out in Alex to get the practice on these problem sets. Okay. Any questions on 4.6? First tangent graph again. Yes. Give me a second. Was this the first? Yeah. Is that the one you are asking for, Kennedy? All good?
After
Yeah,
this
Michael,
one,
do you have
could
a
you go to the
question?
secant one or the
Secant.
cosecant graph?
The cosecant?
Yeah. Just take a picture. All right, thank you.
Uh-huh. All right, so now let's talk inverse, right? So when we did the college algebra portion of the class, we had a section where we looked at inverses, right? And that's where if I switch my x and y values and then resolve for y, then I end up with my inverse, right? So we can have inverses in trigonometry as well, except we don't have as much liberty of the domain. Take, for example, with our tangent or our cotangent, our cosine and sine, before our domain was negative infinity to infinity. But if we're talking about the inverse, then that is different, okay? And so what I want to point out here is when we're looking at our inverses, we have some restrictions, right? So let me just make sure what's on my, yeah, I'll just come over to this one. So when we're looking at that restriction, right? Right now, we're just looking at this blue graph up here. This is if I were to graph my sine, just a regular old sine, then I can go from negative infinity to infinity, right? If I'm looking at my inverse, then my domain is restricted from negative infinity to, negative pi over 2 to positive pi over 2, and it can be inclusive, right? So if I draw this, it's telling me I'm restricted and I can only go from negative pi over 2 to positive pi over 2. So that means I can only be in these two quadrants, right? So I can go from here to here or from here to here, but I can't actually cross those lines. And that is because when we're doing inverses, and you know how we flip and swap the x and y values, we get into some troubles with things being undefined. So the domain is actually restricted for negative pi over 2 to pi over 2. So if my inverse is negative, it's going to be in here. And if it's positive, it's going to be in here. So I point this out because if you were to put something in your calculator to come out with something, you could get the wrong answer if you don't really particularly know and understand these inverses and you're relying on a calculator to do it for you. Because calculators don't take into consideration that there are two potential places for an answer, but when you're dealing with an inverse, it can only be one of them. Okay. So you might see it written as sine with this raised to the -1 power. You might also see it written as the term arc sine, okay? With the arc sine and the sine inverse, they mean exactly the same, okay? And again, you can go from -π/2 to +π/2 as your domain, okay? Then I have a couple of examples, and you'll see the picture that I actually have over here in this corner for you, where it shows you that our arc sine is positive in quadrant 1, our arc sine is the negative values when we're in quadrant 4. Okay. So, looking at this first example, we have sine inverse of -1/2. So this is really saying that y, so one thing I will say is this is just saying equals y or whatever, right? So I can very much like with the ln and log, I can, if I want to multiply this side by sine, I can multiply, it has to be in the front, right? I can't put y sine. No, it has to be, what in the heck? It has to be in the front of it. So let me undo that for a minute. Just want to move it so it's not on top of. Okay. So it has to be in the front. So when you put sine and sine inverse together, they undo each other. That essentially cancels out. Okay. So that's why we do that. That cancels out with itself. And it leaves you with sine y is equal to -1/2. Okay. Question. All right. So now what? So what I would need to determine is if I look at this and I want to determine where does my sine equal -1/2? Well, all students take calculus. Sine is positive here, here, negative here, and here. So that tells me then that I'm negative here and here, right? But we have to remember that when we're dealing with inverses, we can only be in the first or fourth quadrant. Therefore, our solution can only be here. So what is -1/2? -1/2, that sine is my opposite, which means my y value is this -1 and my hypotenuse is 2. Therefore, this here has to be the square root of 3, meaning that this here is 30 degrees. If that's 30 degrees, that's equivalent to π/6, right? So, but I can't say that this is whatever that is. Nope, we can't do that because we're crossing bounds. So what I have to say is that y is equal to -π/6 because that's what gets me to that point. Okay, question. So this here is my reference angle. This is my actual angle. Question? let's do the next one. So we have our arc sine is, let's say that is equal to y. Let's take the sine of both sides. Sine and arc sine cancel with each other. So that gives me that my sine of y is equal to the square root of 3/2. Now, in this case, it is positive. So I'm positive here and here. Again, we have to keep in mind, we're dealing with an inverse, so it has to be in the first or fourth quadrant. So what is our reference angle? So this one, let me make those green. This one, I am my opposite, square root of 3/2. So this gives me a 1. So this has to be my 60 degrees. So 60-degree angle is equal to pi/3. Okay. But in this case, it's in the first quadrant. So y is pi/3. My reference angle and my actual angle are the same thing. Okay. Question.
Wait, for the arc sine, you timesed it by sine.
Say that one more time.
For number 2, you timesed it by sine, right? That
Essentially, you're putting sine, right? So if you had sine and arc sine, when they're right next to each other, that equals 1.
oh, okay.
But if I put sine on the left-hand side, I have to do it on the right-hand side. But what I'm saying is, for this, I couldn't have put arc sine square root of 3/2 and then sine over here by itself, because then I would have had y and then sine over here by itself, and that doesn't make sense. So they have to go in front of each of them, or it doesn't work. Okay.
Okay.
Any other questions? And so then let's look at this last one here, on the signs, right? So if we are looking at this one, that equals our y. Taking the sine. Okay. Take the sine and those will cancel. And so that leaves us with the sine of y is equal to 5 pi/4. Well, 5 pi/4 is greater than 1, so it does not exist. Because remember, we still have that restriction where our sign has to be between -1 and +1. So if we have something here, if you put in your calculator 5 pi over sine inverse of, if you put in your calculator also sine inverse of -1/2, you would get the decimal approximation of -pi/6. Same for the others, right? But I don't even encourage you to use your calculator, because you have to show your work on an exam. You can't rely on a calculator for this. You can only use a calculator to check your work, but you can't use it as your work. Okay? Questions? Okay. So the inverse of cosine is it's the same, right? Except now with cosine, we're going to be restricted to our first and second quadrants, okay? And our tangent, like our sine, is we are going to be restricted to our first and fourth, okay? So that's really just what those are telling us, but we'll see some examples here. So cosine is here. Let's do cotangent and cotangent. I mean, tangent and sine are in those two quadrants, okay? So all of them are positive in quadrant one, all inverses. Sine is negative in the fourth. Tangent is negative in the fourth. And the cosine, the inverse cosine is negative in the second. Michael, did you have a question?
Oh, I didn't realize I was unmuted.
Okay, no, I just wanted to make sure that if you had a question, I'm happy to pause. All right, any questions so far? All right, so let's go ahead and look at a couple of examples of these then. So the first one, we're looking at the arctangent of 1, or arctangent 1. So that is really, we're just saying equals y, right? So if I take the tangent of both sides, that's going to go away. And so I want to know, where does the tangent of y equal 1? Okay. Well, tangent of y is positive here and here. Okay. But we know that we must be in the first or fourth. So that tells us which one we're going to choose, the one that's in the first quadrant. And so that happens when we draw this here, tangent 1 over 1. So this has to be square root of 2. That is at a 45-degree angle, or pi over 4. So we know that our y is equal to pi over 4. Okay, question?
Yeah, so for the degrees, you just have the unit circle memorized.
So for me, I don't memorize the unit circle. So I do it based on those two special triangles, right? So if this is 1, that means 1 over 1. Tangent is my opposite over my adjacent, right? And because I know those two special triangles, I know that I have 1, 1 square root of 2. So that's a 45-degree angle. And then my other special triangle is the 30-60. The 30 gets the square root of 3 because the 3's go together. And so this is a 1 and this is a 2. So I don't actually, I don't have the unit circle memorized. I really just rely on these two triangles.
Okay.
And I'll go ahead and slide these over here so we can just keep them. We'll put them in a different color so that they don't blend in with our work. Okay. So for this next one, equals y, so we're going to do the cosine now, right? So that those can cancel. So that tells me that the cosine of y is equal to negative 1/2. I know my cosine is negative in the second and third quadrants. I also know it's an inverse, so I can only be in the first or second quadrant. So we go ahead and build our reference angle from here. Cosine is my adjacent over my hypotenuse. So this is my adjacent side, because remember, it's always the angle in with the origin. So my adjacent side is -1 and my hypotenuse is 2. So when I look over here and I see a hypotenuse of 2 and I have one of my sides as a 1, then I know that this side must be a square root of 3. And therefore, this is my 30 degrees. So this here is 60 degrees. 60 degrees is the same as pi over 3, because that's 1/3 of 180 degrees. So 1/3 of pi is equivalent to that. So, but the reference angle is pi over 3 or 60. So my actual angle, which we're trying to discuss, that's going to be my 2 pi minus, I mean, not 2 pi, sorry, just pi. That's pi minus pi over 3. So that is equal to 2 pi over 3. So here for this, then my y is equal to 2 pi over 3. Okay, question. Okay, so let's look at this one. We have cosine of y is equal to the square root of 3 over 2. So we sketch that out. This is positive here and here. Remember, we can only be, it's cosine or arc cosine, so we can only be in the first or second quadrant. So we'll drop this down here, and my adjacent is square root of 3, right? Because that tells me the adjacent side over my hypotenuse, which is 2. So this must be a 1 because it's that special triangle here. We have to have those 3 pieces. And so remember the 3's go together. So this here has to be a 30-degree angle. If that's 30 degrees, that's the same as pi over 6. Okay. So here my y must equal pi over 6 because we were in the first quadrant. So it's the reference angle and the actual angle are the same. Okay, questions? This last one, we take the tangent. Okay, so this is, where does the tangent of y equal 0? That is like 0 over 1, right? So my opposite is 0, so that means I'm here, and my adjacent is 1, so I'm here at this point. Sorry, wrong one. Yeah, there. Tangent. So my opposite, meaning if I were to draw this, that's 0, so I didn't go up at all. And my adjacent side is 1, so this is this 0.10 here. And so my y is 0. We can see that. So it's actually on the quadrant. Okay, question. All right, so if you have a calculator, go ahead and get them out. And we're going to do just a little bit of practice how you can calculate certain things using your calculator. So be very careful when you see things that ask for an exact solution, then there's no decimal approximation. If you provide a decimal approximation, then it will be marked incorrect, okay? And so for this one, if you put in your calculator, I'm going to pull my cell phone out and turn it sideways. So if you don't have a calculator, you can pull out your cell phone. Again, you can't use a cell phone on your exam, but you could use it, you know, in homework practice. It's always better to practice with the system you're going to use. But anyway, so on your on your cell phone, you'll see this button that looks like these two arrows. If you push those, then you'll notice where it says sine here, it then puts you the sine inverse. Okay. And so what you can do is, so here is arc cosine. So you'll want to put the cosine inverse key. You push that, and then you put parentheses 3 divided by 5. Close your parentheses, and what do you get? When you hit enter, you should get 53.1 degrees if you're in degree mode. Change to radians, and you're going to get 0.9273 radians. Okay, questions? So I'm going to give you guys about a minute to try these other two. Let's try the sine inverse and the tangent inverse and see what you come up with. All right, can somebody share with me what you got for the sine inverse of negative 0.457?
Is it negative 0.476 or 4746?
4746, that's radians, right?
Yes, radian.
If you happen to do the degrees, you can just push the key and switch it. You shouldn't have to retype it.
Oh, in degrees, is it negative 27.1937?
Yep. So we'll just put negative 27.2 degrees. Okay. Anybody have questions on that? What about the arc tangent of negative 2.09?
Negative 1.1245 radians, and for, let me see, and then for the degrees, negative 64.4.
All right, perfect. Does anybody have questions on how to use your calculator to get the inverses? So these are inverses of things that we don't actually have a special triangle to get an exact precise, right? So there's that. So this other example here, we want to use a calculator to approximate the sine of 3/8, right? So that is sine of theta equals 3/8. So this is my opposite over my hypotenuse, right? It tells us that we are 90 to 180 degrees, right? So it's telling us we're over here in this one. We know that our sine is positive in 1 and 2. So this tells me I'm looking at this. So I'm looking at 180 degrees. Well, first, I don't know what this is, right? What is my reference angle here? Well, if it's a reference angle here, it's the same amount. It is the same amount over here in this amount, right? So this reference angle is the same as this reference angle. So let's find the reference angle for here because we can only do inverses in the first and fourth quadrant for sine. So if I do theta is equal to sine inverse of 3/8, then that's going to give me, if I put that into my calculator, and I put sine inverse 3/8, then I get approximately 22 degrees. Okay. So if I want to know how much this angle is here, right? So this is approximately 22 degrees because this is 22 degrees. So I can do, geez, I could do 180 minus 22 degrees, and that's going to give me approximately 158 degrees for that angle. So when I want to know an approximate angle measure where my sine is equal to 3/8, I can do that, but I have to use inverses. I have to do inverses to get that, okay? And so in order to do an inverse, I have to do those calculations based on the reference angle and then interpret it over into the angle that we're actually looking for, okay? Question. Okay. So this is all, it's all an extension, right? I've already kind of been telling you that if we're looking at sine times sine inverse, tangent times tangent inverse, and so on, that those kind of counter out each other. So we're going to take it a step further now, and we're going to start applying it to other situations. So if we have, like we have here, and if we have the arc sine times the sine, those are going to cancel with each other, right? And that's going to just leave us with negative pi/6, okay? When we look at this one, though, we have the arc sine and the sine, okay? Those cancel, but 7 pi/6 is outside of the negative pi/2 to pi/2. So you actually have to rewrite this, right? Because sine is negative in those two quadrants. Knowing it's an inverse, we know we have to be in these two. So I can't say that my answer is, I can't get at it like this because I cross into the unknown boundary. So I have to translate this into the appropriate lingo. And so that would be negative pi/6 because I would have to come at it from this direction. Okay. So I cannot come across that boundary. Okay. Question. So now again, the same with the cosine. So we have this 7 pi/6, right? Our cosine is, we can look at our cosine. Where is it going to be? Let's go ahead. Did you have a question?
Oh, oops, my bad.
Nope, not a problem. So when we're looking at this, and we're looking at this angle here, 7 pi over 6, right? That's what we're looking at here. Well, the thing of it is 7 pi over 6, that is outside of my range for my cosine, right? So that angle, my cosine is negative, so my cosine will also be negative up here. So we're really just rewriting it up here as we did here. We rewrote it to reflect into the appropriate category, right? So if I'm looking at at that, my reference angle here then is this reference angle is pi over 6, right? Because that is, so the reference angle is going to be pi, 7 pi over 6 minus pi. So that is, my reference angle is pi over 6. So if that reference angle is pi over 6, then this reference angle is also pi over 6. If that is pi over 6, then this is pi minus pi over 6 or 5 pi over 6. And that would be our solution. Okay. So it's all about manipulating it so that we're not breaking the rules of inverse. Okay, questions? Okay. And for this last one, we have the cosine inverse. Well, remember, cosine itself is an even function, so this one would just be the -1. Okay. So we could, it would, it's sufficient to do that. Okay, questions? Okay, so now what happens when we don't have sine up against sine or cosine up against cosine? Okay. All right, so actually, you know what? I'm going to give you guys, let's take a 10-minute break. And come back at, so it's 7:15, let's come back at 7:25. Okay, and then we'll finish out this section and answer any questions. Just because we have a few more slides to get through, which would take us past the 7:30 mark. And so this would be a good place to pause and take that 10-minute break. Okay, so we'll come back at 7:25. All right, it is 7:25, so let's go ahead and carry on. So now we're going to look at what happens if we don't have just sine and cosine to where we can cross them out, right? And so in order to do that, we have to kind of do it in a two-step process. So first, we'll solve the inside part, right? So basically, we could say, okay, our angle is equal to the sine inverse of 40 over 41, okay? So if I take the sine of both sides, right? Now those are going to cancel, and that gives me the sine of theta is equal to 40 over 41. So let's sketch this out. So positive x and positive y. My sine is opposite over hypotenuse. So I can calculate this, right? I could say x squared plus y squared equals r squared. Well, my y is 40. My r is 41. Okay. So that gives me x squared is equal to 81. So x equals plus or minus 9. We're in the first quadrant, so we choose the positive, and so we've calculated our x value to be 9. Okay. Now, from here, what is from that picture that we have created, what is cosine? Okay. So my cosine of that picture, remember cosine is of my angle is my adjacent over my hypotenuse. So this is going to be my 9 over 41. Okay, so when we're asked to determine the cosine of sine inverse of 41, well, then that solution is 9 over 41. So what we do is we sketch out the inner piece, and then once we have that graph depicted, we determine the outer piece. Okay, question. So the problem right next to it is we're looking at the inner piece here first. So that's going to give me the sine of negative 40 over 41, right? So we're just, I skipped a step. So we have that our theta is equal to sine inverse of negative 40 over 41. We're going to take the sine of both sides. So sine of theta is equal to negative 40 over 41. Okay. So now my sine is negative in the third and fourth, but we're restricted to the fourth. So we draw that in here. Sine is my opposite, so that's negative 40 over my hypotenuse, which is 41. We already did the calculation on using the Pythagorean theorem. So we'll know that that is still going to be 9 because the values didn't change, just the signs did.
Quick question.
Yes.
So just to confirm, the sine can only be in quadrants 1 and then quadrant 4, right?
Correct. For inverses.
Yeah, for inverses, I mean, because for non-inverse, it's quadrant 1 and 2, right?
For non-inverse, sine can be in all 4 quadrants.
Oh, okay, yeah. So is sine and cosine quadrants 1 and 2?
No, sine, remember sine and tangent are quadrants 1 and 2.
Okay.
Cosine is sine and tangent are 1 and 4. Cosine is 1 and 2.
Oh, okay. Thank you.
Uh-huh. Okay. So now when we look at this, we want to determine, we're looking for cosine. So cosine here of theta is equal to 9/41. So you'll see that they're exactly the same, right? For this particular problem, but it won't always be that case. But the sign can be different, but the cosine didn't happen to be in this case when you look at it. Okay? Questions? Okay, so this last example that we have down here is if we're looking at the arc sine of 2/x, that is, we're saying theta is equal to arc sine 2/x. So taking the sine of both sides, right? That gives us that sine of theta is equal to 2/x. Remember, that is our opposite over our hypotenuse. Okay, so if we look at it just in a right angle, we can see that it's our opposite over our hypotenuse, right? Let's just call this side A. So we're going to have a squared plus 2 squared equals x squared. So a squared equals x squared minus 4. So a equals the square root of x squared minus 4. So we would just say here then that our tangent of theta is our adjacent over our, it's our opposite over our adjacent. Our opposite side is 2. Our a or adjacent side is the square root of x squared minus 4. So if you had to kind of look at one in terms of trying to solve it algebraically, because we have a variable in it, we could do that as well. Just think of it in terms of, just a right triangle. Or you could put it in the first quadrant, it's fine. If it's positive, fourth quadrant if the sign is negative. Okay, questions? All right, so let's look at some of our application problems. Okay, so for this one, we have the Eiffel Tower is 1,063 feet tall, and a measurement is taken of the length of its shadow, and it's found to be 310 feet. Approximate the angle of elevation from the sun to the nearest angle. Okay. So first of all, we're looking at something like this, right? And it's saying that we have some shadow out here, and it's at some angle here that we don't know. We do know that the shadow is 310 feet from the base, and we do know that the tower is 1,063 feet tall. So in this case, we have our tangent of theta, right? Because if this is the right angle, I have the opposite and adjacent side. So my opposite side is 1,063. My adjacent side is 310. So similar to getting rid of the tangent here, if I want to get the theta by itself, I can do a tangent inverse, but if I do tangent inverse there, I have to do it on this side as well. So that's going to leave me with my angle is my tangent inverse of 1,063 over 310. So you could put that in your calculator now, right? And you could get that our angle is approximately 73.7 degrees. Okay. Questions? All right, so just as we had inverses with the other three main trigonometric functions, you can also have inverses with the secant, cosecant, and cotangent functions as well. And they would follow similar rules to our other or their reciprocal functions, right? Except that they have slightly different where you could domains, right? So you'll see this one we can be from 0 to 2 pi. So you think about that from 0 to 2 pi. So we can be here. We can also be from pi over 2 to pi, right? But we can't, remember, we can't be on this is the asymptote, right? So we can be in each of those, we just can't cross over one of them. Okay? We can, for our, so that's secant. For our cosecant, it's negative pi to 0, not including the 0, right? See, there's no equality here. And then from 0 to pi over 2. So again, it's essentially, we're going from here to here, but we are excluding that point right here. Just like, let's draw this one again. So we can do those, but we have to make sure and exclude that point. Okay. And you can do for our cotangent, that's going to be from 0 to pi. So that's similar to our cosine, and there's no restriction whether it is, it can be on pi over 2. Okay. So let's look at some examples of these three functions. Okay. So first we have our secant inverse is 2. So if we set that equal to y, we can take the secant of both sides. Okay. So we get that the secant of y is equal to 2 over 1 is really what that's saying. Okay. So that occurs, it's positive in the first and the second quadrant. Remember we, this. So we'll want to choose the one that's in the first quadrant, right? Based on our domain for it. And so here, if my secant is 2 over 1, remember secant is, so my secant is the reciprocal of my cosine. My cosine is my adjacent over hypotenuse. So this is hypotenuse over adjacent. So I know that this here has to be the square root of 3. So this here is 30 degrees or pi over 6. If that's that, and we don't have to worry about that. This one here is 60 degrees or pi over 3. And so we would say here that my y is equal to pi over 3. Okay. Question. Okay, so cotangent. With our cotangent, it's negative, so it could be negative in the cotangent is negative in the first or the fourth. So when we're looking at this one, but we can only be in one of those two, right? So we're going to be looking in terms of the second quadrant here. Oops. So we have our cotangent because we're going to take cotangent of both sides. So we get the cotangent of y is equal to the negative square root of 3. So that's really square root of 3 over 1. Okay. And so this is going to, my tangent is my opposite over adjacent. So this is going to be my adjacent over my opposite. And so this will be a 2 here. This is 30 degrees. If that's 30 degrees, then this is 180 minus 30 degrees. So that's 150 degrees, which is equivalent to 5 pi over 6. So in this case, my cotangent of my cotangent inverse of negative square root of 3 is going to be 5 pi over 6. Okay, questions?
Okay, just to confirm, so each time we're doing this, we're trying to find the corresponding angle that'll make it 180, right?
Yeah, so in this case, we had to align it with 180, right? Because we're in the second quadrant.
Mhm.
When we are determining to get that, we have to use our reference angle for whatever that built, right? So our reference angle ends up being 30 degrees.
Oh, okay, yeah.
Right. Remember, all reference angles are acute, so they're less than 90 degrees.
Mhm.
So now that we know that the piece that it doesn't go all the way to 184 is 30 degrees, we could take the 180 minus that off, and then that's how we are able to determine how much this angle is.
Okay, and so wait, for the last one, did we do 90 minus 30 or what
Well,
did
we were in the first quadrant, so our referencing in quadrant 1, reference angle is equal to the angle.
Mhm.
In
Oh.
quadrant 2, our reference angle is, our angle is 180 minus our reference angle.
All right, so wait, is quadrant 3 270?
Our quadrant 3 would be 180 plus the reference angle.
Oh, okay.
And then quadrant 4 would be 360 minus the reference angle.
All right, thank you.
But remember, if we're dealing with inverses and we can only be in these two, we can't do 360. You can't do 360 minus the reference angle. It would just be a negative reference angle.
Oh, okay.
Okay, because if you did that, then you would have to cross into the restricted area to get to it. Whereas if you did the negative, you just come at it this way.
Yeah. Okay.
Hopefully that helps.
It does. Thank you.
All right, so with our cosecant here, this is equals y, so we're going to take our cosecant, those will cancel, so we get our cosecant of y is equal to negative 2 square roots of 3 over 3. Well, we don't really have anything like that, but what happens, what you can see here is this denominator actually got rationalized, right? So if I have square root of 2 times square root of 3 over 3, if I try to unrationalize this, that's really just re-rationalizing it, right? That's going to give me -6 over 3 square roots of 3. Did you have a question, Zachary?
Oh, no, sorry.
Okay. And then this will reduce to 2 over the square root of 3, right? So if this is 2 over the square root of 3, then when I put that into my thing here, I'm going to be in the fourth quadrant because we're negative here, right? And so if I'm looking at this here, and I have for my cosecant, that's the reciprocal of sine. So that is my hypotenuse over my opposite. So this leaves me a 1 here. So this must be 60. 60 degrees is equal to pi over 3. But I can't do this as I was just explaining, right? Because I break into the restricted area. So I would actually have to say that the solution here is negative pi over 3 because we're going to come from here and go this way. And so my y is equal to negative pi over 3 for that inverse. Questions? All right, so the last problem that we have here is we want to use a calculator to approximate cosine inverse 8 over 5 in radians. And so we have the cosecant inverse of 8 over 5 equals y. We don't have a key for that, right? So, but this translates as cosecant of y is equal to 8 over 5. So if we draw that out over here, that's my hypotenuse is 8, my opposite is 5. When I do my Pythagorean identity, a squared plus b squared equals c squared, or x squared plus y squared equals r squared, I get that my x value is the square root of 39. Okay? So now I can use in my calculator sine inverse of this, which is going to be 5 over 8 because that's the reciprocal, right? I could put that in my calculator and I get 0.6751. Okay? Question. All right, it looks like that has gotten us to the end of this section and actually the end of chapter 4 as well. If you guys have any questions, happy to stick around and answer those. Otherwise, you are free to go, and I will see you tomorrow night. Okay?
So our tests are most likely going to be done graded by tomorrow.
I'm not going to post anyone's grades until I've graded them all.
Okay.
So it will be probably Thursday at the latest.
Oh, okay.
But yeah.
All right. You have a good
I
night.
just take a lot of care and time in grading them because I will give you guys a lot of times I have to look through, like if you miss something, I have to look through all of the work to make sure that where I can give you partial credit. So I do grade heavily on partial credit.
Correct.
Okay. Any other questions?
Yeah, I have a just quick question about what I was emailing you about earlier.
Yeah, so I'm going to stop the recording. Let's